Hello everyone, I'm Jiao, diffuse students in University of Oxford. Today I would like to introduce my work at MIUA 2021. The paper name is the Improved Artifact Detection in Endoscopy Imaging through the Profile Pruning. The endoscope is a widely used clinical produced for excising inflammation in whole organs and performing subsequent treatments. Every endoscopy typically consists of a light source and a camera connected to an external monitor to help clinicians navigate through the urgent of interest in real time. During any endoscopy surveillance of whole organs, the presence of several imaging artifacts, such as the blood circularity, and according to the statistics, more than 60% of endoscopy videos frames can be affected by artifacts. The artifacts affect the quality of diagnosis and treatment, as they can obscure the features relevant for assessing inflammation that are characteristic to procedures of concern. In addition, they affect any automatic analysis. It is therefore desired to detect and localize areas that are corresponded by artifacts such that these frames can either be discarded or the presence of these features can be taken into account during diagnosis, such as an approach can largely minimize the amount of fuse detection rings. We proposed a comprehensive artifact detection method that comprise of the bounding box prediction using efficient net with a direction feature layer and the NMS to optimize the predictions and the proposed artifact profile-based pruning of the artifact instance boxes. We firstly use the efficient night as the backbone for the efficient data and stack the bidirectional feature network layers to obtain the high-level fusion features. And the design of the layer comes from the past algorithm network, and it removes the node with only one input and connects the input and output nodes of the same level. The entire layers are used as a base layer and are rapidly connected this 3 times as a feature network. It takes P3 to P7 features from the backbone network and rapidly two-way feature fusion. Both the bounding box and class prediction network can share features and produce the bounding box prediction and object classes respectively. And we modified the class prediction network for classifying 8 category classes. And then we proposed this novel pruning method. We first compute the mean probability distance distribution along the horizontal line profiles of each category in ground truth annotations present in all training samples. And for this, the degree value distribute of the horizontal central line is computed in each bounding boxes, and among all the profiles in each category, we calculate the median lines of them as the average lines of this category, and then we select the threshold of 20 pixels to cut and filter out all profiles. After processing all profiles in the same categories have the same lines, and the mean gray value of each pixel is then calculated. And then the prediction results obtained by the efficient data model include the prediction categories, confidence score, and the bounding box information. We compute the vertical distance between the two probability distance distributions to reflect the difference between them. In addition to the confidence score, we obtain another evaluation score, the vertical distance score. Smaller vertical distance means the probability distance distributions in two profiles are more similar. And then we used the dataset from the endoscopy artifact detection challenge 2020, and it contains of 2,200 single endoscopy frames and 233 sequential frames. Each frame includes an image frame and its corresponding bounding box annotations and category labels. And we also use the focal loss for the classification task and smooth L1 loss for the regularization. It can be seen that the efficient date zero model got overall the MAP of 20.29% and an IOU of 5.70%. And this means the model over-predict the class instance with poor localization. And then after the NMS, the overall MAP dropped to 19.93% with increased IOU by about 6%. And by using our proposed technique, the result are improved. It can be observed that with technique, we achieve an overall MAP of 21.33% and an IOU of 19%. Similarly, we observed the improvements in MAP at other the result. And also the result after the NMS process have been significantly improved, but there is a large number of the wrong bounding box predictions. And our PDF-based post-processing method further optimized the result and reduced the incorrect prediction bounding box. In the original prediction of the model, there is a large number of the wrong results between the different categories, especially in the scalarity and artifacts. From the quantitative result point of the view, our results have fewer and more accurate annotations bounding box, which can be observed to be closer to the ground truth annotations. So in this paper, we proposed a novel method of elimination the wrong prediction based on the distance between the horizontal line profiles of the prediction bounding box with that of the pre-compute ALTUS line profiles. And the experimental results shows that our method effectively improves the mean average precision and the intersection over onion. In particular, our method can be applied to any deep learning based object detection model. And in the future, we plan to integrate the proposed profile pruning technique within the end-to-end learning framework and maybe implied the pruning as the loss function in the training process. And thank you for watching my presentation on the MIUA 2021. And it is my pleasure to talk with you today and introduce my work. Bye.